Section 2.5, solving linear inequalities as opposed to equations. So inequality symbols, perhaps you have seen these before. Arrow to the left, that means greater than. Arrow to the left with the equal, greater than, or equal to. Arrow to the, those are right. Arrow to the left, this is less than. An arrow to the left with the equal sign, less than or equal to. So we're still dealing with linear. That means the powers of x in our inequality will be 1, right? And this is how they look like, something x plus some constant greater than c, or less than or equal to c, or just less than c, or greater than or equal to c. So we use these symbols to avoid writing the statements in English. For instance, a number smaller than 5, instead of writing a number smaller than 5, in the land of mathematics, a number means x smaller than 5, so that's how you write smaller than 5. Notice the arrow points to the smaller number always. A number greater than or equal to, let's say, 10. So that would be a number. So we show the number, unknown number with x. And greater than or equal to, so there you go. Greater than or equal to 10. So that's basically how we use the notation. So notice less than points to the left, greater than points to the right. So how do you read these inequalities? So the first one reads 2x minus 7 is less than or equal to 10. Notice I read the inequalities from left to right. This guy reads x is greater than the left number, but less than the right number. So is greater than or equal to 5, but, or you can use the word and, less than or equal to 12. So it's always greater than the number on the left, smaller than the number on the right. So this is the smaller number, that's the greater than number. So this guy reads x is less than negative 10, or x is greater than or equal to 8. That's how you read this, correct? So now, how do you graph the inequalities on a number line? So when you say x is greater than 3, here's a number line with a 0. So you go 3 units to the right side. It's greater than 3, strictly greater. It's not equal, so you use open dot. And greater means the arrow goes right. So less than, arrow goes left. Greater, arrow goes right. And because it's open dot, so notice it's open dot because no equal sign in our problem. Do you see it? There is no equal sign. However, here we have an equal sign. So I gotta go 2 units to the right with a closed dot. So this would be closed dot. Why? Because of the equal sign. Is that right? And it's less than, so the arrow goes left. So this indicates all the numbers greater than, strictly greater than 3. And this is like all the numbers equal or less than 2. These are called compound. This is called compound inequality because it's like 2 inequality in 1. So here you go -1 and 1, 2, 3, 4, 5 right here. Right above -1, we have an open dot because there's no equal sign. Right above +5, we have a closed dot because we have an equal sign. And x is a number between -1 and 5, so we connect the dots. Do you see it? So this reads x is greater than -5, but less than or equal to 5. Notice smaller numbers goes to the left, larger number goes to the right. And we always connect the dots when we're dealing with compound inequality in this form. So x is greater than -1, but less than or equal to 5. So that means x can take any value between -1 all the way to 5 and including 5. What about between 0 and 4? 1, 2, 3, 4. Both of these guys have equal signs, so both of those guys take what? Closed dots. And x is somewhere between what? This smaller number and what? The larger number. So once again, we connect the dots. Sometimes you have two separate arrows, and the way you know that you have two separate arrows, you should see the word or in between the inequalities. X is less than 2, so that means what? One arrow goes this way. Remember, less than indicates what? Left arrow, or I should say arrow points what? To the left. And the greater than sign, arrow points to the right. Is that right? So now x is greater than or equal to 4, that's 3, 4. And it's closed because it's equal sign and goes to the right. Notice there is a gap between what? These two inequalities. And the way you know there is a gap, you should see the word or. In other words, you are under on 405, freeway 405 or 91. You can't be on both at the same time. It's either or, but not both. You see it. So less than sign, as I said, left arrow, greater than sign, right arrow, and we always read the inequalities from left to right. Yes, from left to right. All right, solving inequalities. This is just like equations. So we what? Collect x's to the left and numbers to the right, just like equations. So in this case, we subtract 2. So keep track of your inequality sign. Divide both sides by 3. So x is less than or equal to, excuse me guys, this is supposed to be 6, less than 2. Is that right? So how do you graph the solution? The solution looks like this. Here is 0, here's 2. We have a solid dot. Less than means the arrow goes left. So this is the solution. And this is the graph of the solution. Graph means what? Picture. Okay. What about this guy? Well, this guy, you subtract 3, just like equations, but keep track of the inequality sign. But the only problem is now you have to divide both sides by -4. When you do that, the sign, the inequality sign switches. 8 divided by -4 is -2. So notice the inequality sign switched. Why did we switch the inequality sign? Here is the reason. When you have, let's say, 2 is less than 4, and you add what? Or subtract a number, the inequality sign does not change. For instance, if I add 5 to both sides, I get 7 is less than 9. Still true. Or even if I subtract, let's say, 2 from each side, I get 0 is less than 2. No problem. On the other hand, if I multiply both sides, let's say 2 is less than 4, by a positive number, so if you multiply both sides, let's say by 3, you get 6 is less than 12, no problem. The inequality sign has been preserved. 6 is still less than 12. However, if you multiply or divide both sides by a negative number, then the inequality sign gets to switch. For instance, remember we had 2 is less than 4, but let's say we multiply both sides by -1. When we do, we get -2, -4. But -2 is no longer less than -4, it's greater than -4. Therefore, here is a fact of life to remember when you are in section 2.5. The only time we flip the inequality sign if we ever multiply or divide both sides of an inequality by a negative number. That's also true when you divide both sides by a negative number. Remember, 2 is less than 4. But if I decided to divide both sides by -2, I get -1, -2, but -1 is greater than -2, not less than. So notice we need to switch what? The inequality sign. That would be the only difference between solving inequalities and solving equations. In inequalities, be careful. Everything looks like, as if you were solving equations till you get to a point where you divide or multiply both sides by a negative number. Then don't forget what? To switch the sign. Yes, switch the inequality sign. Inequality sign. So that's the only thing to remember. Okay, solve and what? Graph the solution on a number line. So here's the first equation. Remember, we read the inequalities from left to right. So you read this as 2x plus 3 is greater than 4. So solve for x. So remember, the idea is solve. Just like equations, we collect the numbers to the left, subtract 3, so you get greater than 1. Divide both sides by 2. Notice I don't have to switch the sign because I divided both sides by positive numbers. So no need to switch the sign. Do you see it? So the answer is x is still greater than 1/2. So here is 0, here's 1, 1/2 is halfway in between. There is no equal sign, so we have an open dot. Remember, greater than goes right, the arrow goes right. Less than, the arrow goes left. So I gotta have an arrow going right. So what does that mean? That means you have many solutions to this problem, as long as your solutions are greater than but not equal to what? 1/2. This guy reads -5 times 4x minus 2 is less than 5 minus 4x. Remember, we always read the inequalities from left to right. Okay? Just like equations, first we need to what? Remove the parentheses, so that would be like -20x, positive 10, less than 5 minus 4x. Then we need to collect the x's to the left, numbers to the right. Remember, the reason we collect the x's to the left because we read the inequalities from left to right. So I'm gonna what? Add 4x to both sides, just like equations. So I get what? Negative, what is it? 16x plus 10 less than 5. Then I'm gonna, just like equations, subtract 10. Is that right? And I'm going to end up with -16 is less than -5. But then I'm going to end up what? Dividing both sides by a negative number. Do you see it? So what was the rule now? Before you forget, remember to switch the inequality sign. Why? Because you divided both sides by a negative number. So x is greater than negative over negative is positive, 5 over 16. So 5 over 16 is somewhere out, I would say here, I'm just guessing. So greater than 5 over 16, that should do it. Do you all see it? Sometimes we have fractions, just like what? Equations. In this case, the first step is to clear the fractions, right? To clear the fractions first. How do you do that? Give a denominator of 1, 2, 3, and then find LCD of all these denominators, 2 and 5 and 1. What is the lowest number that each of these numbers divide into? The answer, 10. So multiply both sides by 10. So multiply both sides by LCD. Okay, so that would be 10 x over 2 plus 4 over 5 less than or equal to 10 times 3 over 1, correct? So now, because I'm multiplying both sides by a positive number like 10, I don't need to what? To switch the signs. But now I have to distribute the 10 to remove the parentheses. 10 over 1 times what? X over 2 plus 10 over 1 times 5 over 4 less than or equal to 10 over 1 times 3 over 1. So inside each of these boxes, you multiply the fractions out. How do you multiply fractions? You cross-reduce them first. So you kind of go 2 goes into 10 5 times, 5 goes into 10 twice, and there is nothing to cancel on the right side. So the bottom line is you get 5x plus 2 times 4, which is 8, less than or equal to 3 times 10, which is 30. So no more fractions. That was the whole idea behind multiplying both sides by LCD. Subtract 8. So we get 5x less than or equal to, what is it? It's 22. Is that right? Divide both sides by 5. So x is less than or equal to 22 over 5. 22 over 5 is 4 something. So just go on a number line. Here's 0, here's 4, here's 5, somewhere out here. Just put a closed dot and arrow goes left. Do you see it? And it's open, closed dot because we have a what? Equal sign. Very nice. So this one also has a fraction. So if you have fractions and whole numbers in equations or inequalities, change the whole numbers into fractions by giving a denominator of 1 to them. Find the lowest common denominator of 5, 15, 3, and 2. Well, it turns out the answer, I believe, is 30. That's the lowest number 5 and 15 and 3 and 1 divides into with no remainder. So multiply both sides by 30. So x over 5, 18 over 15, greater than what? 30, 2/3 x plus 2 over 1. Right? So let me get a nice clean piece of paper so we can continue this on the next page. So what do we get here? Well, if you distribute the 30, is that right? So what that means, you write 30 twice on the left, is that right? And twice on the right. Why is that? Because you have 2 fractions on the left and you have 2 fractions on the right. So write 30 next to each of these fractions inside the parentheses. Now take a look at these boxes. Right? Inside each of these boxes, you are asked to multiply 2 fractions. How do we multiply 2 fractions? We cross-reduce them first. So 5 goes into 36 times, 15 goes into 30 twice, 3 goes into 30 10 times, And there's nothing to cancel on in the last box. So let's see what we got left with. 6x minus 16, that's 2 times 8, greater than, what is it? 20x plus 60. That's 2x times 30, and that's 30 times 2. Collect the x's to the left, so subtract 20x from each side, so you get what? Negative 14x. These guys cancel. Add 16 to both sides to get rid of the negative 16 on the left. These guys cancel. And that would give you 76. Divide both sides by negative 14. Is that right? And note, we have divided both sides by what? By negative 14. So it's a negative number. So we need to switch the inequality sign. The inequality what? Sign. So because it used to be greater, now it's going to be less than, right? So x is positive over negative is negative. And you have 76 over 14. Is that right? So, so if you reduce this, say, by 2, that would be 3. That would be what? 638, 7. So there you have it. And that would be like x is less than negative 5 and 3/7. Right? 35 and 3, right. So what do you do now? So you kind of go on a number line. Is that right? Here's 0, 1, 2, 3, 4, 5, 6. Is that right? So the answer is somewhere out here, right? Between negative 5 and 6. We have an open dot. It's less than, so the arrow goes to the left. And that's pretty much the graph or the picture of the solution, which reads x is less than negative 5 and 3/7. Incidentally, you could have just left it as negative 38 over 7. The reason I changed it to mixed numbers so I can tell exactly where the solution is located on a number line. So that pretty much does that guy. Okay, so now let's solve a few more examples. Sometimes you are asked to solve these kind of problems. These are called compound inequalities. That means two inequalities in one. The way you read this, you go x minus 6 is greater than what? The left number, but less than or equal to what? The right number, which is negative 5. So you read it inside out. So the idea is what? To have x isolated in the middle. That's the objective. Okay, so what do? Start with the original problem. Okay, get rid of the negative 6 by adding 6 to each side, middle, left, and right. So you kind of go like this. So these guys canceled. X is greater than negative 1, but less than or equal to 1. So how does the picture look like? Well, here is a number line. Here is negative 1. Here is positive 1. Right above negative 1, you have an open dot. Right above positive 1, you have a closed dot. And x is in between, so you connect the dots. So that's called compound inequality. Compound meaning what? You have more than two inequalities, because this guy reads x minus 6 is greater than negative 7, and x minus 6 is less than or equal to negative 5. So it's two inequalities in one. What about the next one? You see a fraction here. Give a denominator of 1 to these whole numbers. Find the lowest common denominator between 1 and 2 and 1, which is 2. multiply each side, left and middle and the right, by LCD to clean the fractions. So you kind of go like this. 2 times 5, 2 times what? 3x plus 1 over 2, and 2 times 11 over 1. Why did you multiply both sides by LCD? So in the middle, the 2's cancel. On the left side, you get 2 times 5, which is 10. Okay. On the right side, you get 22, because that's 2 times 11. Now try to isolate the middle for x. You should have nothing but x in the middle. So subtract 1 first. Okay. So these guys cancel. So you get 3x is less than what? 21. But greater than or equal to what? Positive 9. Now divide each side by 3. So you get what? X is greater than or equal to 3, but less than what? 7. So that's the solution. And the graph of this guy looks like here is 3, here is 7. Right above 3, you have a what? Closed dot. Right above 7, you have an open dot. Connect the dots, we are good to go. Sometimes when you're doing problem in this section, you'll come across to 2 different ways of showing the inequalities. One is called interval notation, the other one is called set notation. So let me show you a few examples just in case you come across to these type of notations so you won't panic. X is greater than or equal to 5. Let's just graph this. So here's 0, here's 5, a closed dot. Greater than or equal. Greater means the arrow goes right. So for interval notation, you use what? Brackets for closed dots. So let me just make sure we all see it. Where would I put it? Right here. So we use brackets for closed dots and parentheses for open dots. So brackets, closed dot, is that right? Parentheses, what? Open dot. There. So because this guy, remember we go from left to right. So you go 5 and more, or greater than or equal to 5. So we start with what? 5. And it goes all the way, what? To Neverland, which is called positive infinity. Infinity is a huge number on the right side of the number, which we never ever get there, right? It's greater than the number, greatest number you can ever imagine. So brackets 5, positive infinity, parentheses. Notice infinity always takes what? Parentheses. You can never include what? Infinity with the brackets. In case if you do, that means what? When you get to infinity, stop. Well, we don't know how big infinity is. Infinity is a never-ending number. It could also what? We could also have negative infinity on the left side of the number line. So how would the set notation look like? You go x bar, which means this reads all values of x. Bar reads such that x is greater than or equal to 5. That's set notation. So you read this all values of x such that x is greater than or equal to 5. So this is interval notation, this is set notation, and either of these or even this is acceptable in exams or homework or whatever. So I'm not picky. So for those of you who will be taking more advanced courses in algebra, it'd be nice to learn these notations. This is the notation we use in like higher level math classes. X is less than -2, so here is -2, less than, so it's open dot, no equal sign, less means you're going to the left. Remember, you read these arrows from left to right. So the left is negative infinity, the right stops at -2. Remember, we go from left to right. Left is never-ending small number, which is negative infinity. Right is -2. So you go negative infinity, comma, -2. Parentheses, because infinity never, whether it's plus or minus, gets brackets. And this guy is parentheses because it's an open dot. So parentheses, negative infinity, comma, -2 exactly has the same meaning as x is less than -2. All real numbers less than -2, but not including. In set notation, you go all values of x such that x is less than -2. There you go. What about this guy? Well, this guy here is 0, here is 6. You have closed dot on top of 0 because of the equal sign, open dot on top of the what? 6. This is one of those compound inequalities, so x is in between 6 and what? 0, so connect the dots. So now, remember, when it comes to interval notation, you go from left to the right side of the arrow. So in this case, you start from 0, which is the left side, and the right side is 6. But 0 is what? Closed. So for closed dot, we use brackets. For open dots, we use parentheses. So this is the interval notation for this, which means exactly what this guy says. X is greater than or equal to 0, but less than 6. Interval notation, x is all values of x such that x is between 0 and 6. So this is pretty much the same as this, except we add this funny notation, which means all values of x such that this bar means such that the description of the x. How about all real numbers? All real numbers, remember, that means you're going from negative infinity to positive infinity. Is that right? So you kind of write this as negative infinity to positive infinity. Remember, you're supposed to go from what? Left to right. Infinity never takes brackets, so it's negative infinity to infinity. How do you write this in set notation? All values of x such that x is any real number. There you go, right? So finally, we finish this section with a word problem. The question is, to receive an A in an algebra class, Mary must obtain an average of 90 or higher on 5 exams. 5 exams. If Mary's first 4 exams happens to be 92, 87, 96, excuse me, and 77, what is the minimum? Minimum means what? Smallest. Okay, smallest what? Score that Mary can receive on the 5th exam to get an A in the course. Remember, to find the average, you add your test scores divided by the number of tests. So in our case, these are the scores on the first 4 exams, 92, 87, 96, and 77. But the score on the 5th exam, that's what we're trying to find out. So what we do, we add all the scores. So this would be sum of what? All 5 scores divided by number of exams, which is 5. And that's the average. That's how you find the average. And this has to be greater than or equal to 90 because it says 90 or higher. That translates to greater than or equal to 90. So we say let X be the 5th exam score or the score on the 5th exam. Then we set up this inequality. The left side is what? The average of the 5 exams. And the right side is the average, according to the statement of the problem, has to be greater than or equal to 90. And third step is to solve for X. How do you do this? First, you add up all these scores. Okay. I should have added those scores ahead of time. My apologies. So 92 plus 87 plus 96 plus 77 is 352 plus X over 5 greater than or equal to 90. Correct? Now you have a fraction, get rid of the fraction. Okay, find the LCD of 5 and this guy 1, which is 5. So multiply both sides by 5, like so. Okay, why would I do that? To clean up the fraction on the left side. But whatever you do to the left, you got to do the same thing to the right. So guess what? Now here I have two fractions, 5 over 1 and 352 plus x over 5. To multiply the fractions, I cross-reduce these guys. 5's disappear. So what would I end up with? I would end up with what? 300. And 52 plus x is greater than or equal to 450. That's 5 times 9. So now subtract 352 from each side. Is that right? So x is greater than or equal to what? 98, is it? So what does that tell us? That pretty much tells us that what? Mary must what? Score 98 or higher on the what? 5th exam to maintain what? Maintain an average of 90 or higher to get an A in the course. So the minimum score that she has to get on the 5th exam to maintain an A average is 98. And that's pretty much how you do that problem. Thank you.